Welcome to this unusual edition of Time to React. I hope everyone is safe and healthy. Today I'm going to talk about React hooks and also how and why to write your own. I know from past experience with Time to React that the audience here is pretty diverse, so there's probably a good mix of juniors, seniors, and mid level engineers. This talk mainly caters to those who have at least a foundational knowledge of React and use it pretty regularly. Things change very quickly in our industry, so if you have any constructive and kind feedback for me, I'd be really grateful for it. So my name is Arti Mathanda. I am an engineer at Simply Business. You can reach me on Twitter or GitHub at Arti Smarty. I've been in the tech industry for over a decade now. I started off as a tester, and my last role before switching to engineering was as head of product for a small startup. I had been wanting to get into engineering for a really long time, and finally last year decided to make the leap. Currently, I'm working mostly with React, and I have the occasional adventures with Ruby and Rails. This talk was born out of really a personal desire to learn more about React hooks and how they work. And so I decided to volunteer for this talk because I knew that if I put myself out there in the public, that I would really make sure I knew I would really make sure that I would try to know what I was talking about. And so I'm hoping that from what I've learned, I can help you get a basic understanding of what hooks are, why you'd want to use them, how to write your own custom hooks, and why to write your own custom hooks. The two hooks we'll look at today, well, three if you count the custom hooks. The first two are useState and useEffect. And then the custom hook that we'll write is called useLocalStorage. So what are hooks? Hooks are just standard JavaScript functions that let you hook into React state and lifecycle features from functional components. Before React hooks was released about 15 months ago, you could not have state in functional components. So any component that you wanted state in had to be a class component. React hooks changes that, and now your components can have state. Your functional components can have state. So they're also backwards compatible. What this means is hooks are completely opt-in, and they contain no breaking changes. So your app and your existing state and lifecycle component code and classes will work as usual, and you don't have to go refactor them and add hooks and change them to functional classes, functional components, and also you cannot use hooks in class components. You can mix classes and functional components that have hooks together in a single tree, but you can't use hooks in a class component. Okay, but what are hooks? So let's take a look at our first hook of the evening. This is useState, which is, I think, probably one of the most commonly used hooks. So as the name suggests, useState is a hook that's used to set up and manage state or states. So how does this work? Let's take a look at a simple and somewhat contrived example. This app is basically comprised of two components. One is a functional component at the top, and the other is a class component. And every time you move your mouse over either of the components, it updates the X location of the mouse. So this is how I've written the class component. It's roughly 23 lines of code. You're probably pretty familiar with this if you've written class components with state before. And remember, these 23 lines of code are without constructors or binding or super or any of that stuff because of the relatively new class properties proposal in JavaScript. And this is, the usual declaring the state object, then writing the handle mouse move function to update state, and then the render method. Let's take a look at how this would get done in a functional component. First of all, it's only 14 lines of code. It's almost half of the number of lines of code for the class component. And it's arguably more readable. Let's break it down and compare them together. So in the class component, you declare a state object and declare the key value pairs of each of your states that you're tracking. In this case, location X with the default value 0. When you use React hooks, the way you would do that is you would say const location X, comma set location X equals useState 0. So what this is the useState hook returns a destructured array containing your state initial value and the set location and the set value basically. So in this case, you're tracking location. So you would declare useState by saying location, comma set location. If you were tracking something else like name, so you would say names, comma set name, age, comma set age, etc. And yes, you would use a separate React hook to track each of these different states. And the 0, as I said, is in the use state is basically the default value for the location X. And I don't know if you notice that when the thing loads, it starts at 0 because that's the default value. The next thing is the function to update state. In this case, you say this.setState and you change the value based on what your event handler is sending you back. And then in the functional component, you would use the set location X to update your state. And then finally, rendering the component. Now, obviously, render has nothing to do with hooks, but we don't have a render method in functional components. And then the other difference is that you say this.state.location X in the class component, but in the functional component, you would say just location X. How about if you wanted to track more states? So let's say you wanted to use the Star Wars API to write some kind of app, and you wanted to track, say, planet name, character name, actor name, species name, whatever else. This is how you would do it. Obviously, this can get a bit messy. But there's a hook for it called useReducer. I think John's talk after this is going to go into some detail about Redux and possibly useReducer. So stay tuned for that. And that takes us on to our next hook of the evening, which is useEffect. So the useEffect hook is basically a kind of replacement for component lifecycle hooks, methods from class components. So component did mount, component did update, and component will unmount, all combined together with some slight differences. For those of you who haven't used lifecycle methods before, a really brief intro to it is component did mount is when a component is first rendered in your app. A component did update is when the state changes in the component and so it gets re-rendered. So that's component did update. And component did unmount is when it's removed from the DOM. So the way this works is useEffect is basically takes in a callback and an optional dependency array. The dependency array is what decides when to run the effect once it's already run on mount, which useEffect will always run on mount. So basically, you're telling the effect that after mounting the component, this array has all the things I care about, so only run when these things change. If the array is empty, it just means you only want it to run once, and that's it. Let's take a look at how the different ways to call useEffect. useEffect with just a callback will run after mount and after every re-render. So beware, because if your component has any state dependencies on other components, this will re-render anytime those component states change as well. This is okay for the example that I'm going to show you, which is basically a counter. and so you're not going to do much damage. But if you have a huge app with complex dependencies, then be careful of this. And the way to prevent that is by um, declaring your use effect like this with an empty array and say, okay, just run after mount and don't run again. Just so you know, VS Code has a plugin. If you're using ESLint with VS Code, it won't let you use this as an empty array, and will use the state or whatever you're changing in that array. And we'll see an example of it in a minute. And then the third one is use effect with the callback and something in the dependency array. So in this case, you're saying, hey, run after mount, and if A or B changes, then run it again and call this effect. So let's take a look at this really simple app, which is basically a counter app that starts at 0. You can add 5, you can remove 5, and reset it. We are also going to update the document title when the count changes. So this is pretty simple component. We've written a counter func component, which takes in step as a prop. We've got the state here, which is count and set count. So it's going to keep track of the count as it changes. And the default start value is 0. We've got a few functions here that basically update, increase, decrease, or reset the count. And then here's our use effect hook, which tells the document title to update every time the count changes. And you'll see that our dependency array has the count in it, which is basically telling the document title to update every time the state of count updates. You also have your p tag there, tracking count, and you've got all these functions, buttons that call the functions. If we had to do this in a class component, we would have done it with component did mount and component did update. And as you can see, it's exactly the same thing, whether you use the class component or whether you use the state functional component. And then here, I forgot to mention that in this one, we don't have the count in the dependency array. And this is how it compares to the class component, because we're saying every time the component mounts and every time it updates, change the document title. And then here we're just safeguarding and saying, hey, every time count increases, change the document title. But if this component was dependent on anything else, state of anything else, then don't update it if that state changes. So now let's take a look at custom hooks. Custom hooks have a few basic rules. You should not call hooks from regular JavaScript functions. Call them from React functional components. You can call hooks from custom hooks. So you can use things like useState, useEffect, useReducer, etc. within your custom hook. Your custom hook's name should always start with a use, with the word use, because this basically tells your ESLint rules that, hey, this is a custom hook, so check that it's following all the rules that a custom hook should follow. So to give you an example of how we can use custom hooks and why, let's take a look at this really simple app that you probably heard of this website called, I think it's called Wash Your Hands, where you can create a meme of different songs and to wash your hands to, so that you can remember to wash them for 20 seconds or more. So this app currently lets you choose the song lyrics, but also whether you want to view it in dark mode or light mode. And you click the button and it changes the mode. We've chosen the song, I've chosen the song Wash Your Hands, that is sung to the tune of Baby Shark, and I know it's going to be stuck in your head for the rest of the evening, and I apologize for it. It also updates the document title with the mode currently chosen by the user. So let's see how this is done using both state and effect, use state and use effect. First thing we've done in our dark functional component is to declare state, which is mode and set mode, and the default state is empty, or empty string rather. Then we've got this function that updates the state. So you've said it toggles the state basically. So if the mode is light, then change it to dark, set mode to dark. If it's dark, set mode to light. And then finally, we've got our use effect hook, which is saying, hey, based on what the current value of the state is, update the document title to show me that state. And then we have a div with the class name that chooses which CSS to show, and therefore light and dark, etc. So this is great, but what happens is every time the user refreshes the page, the component has refreshed the default mode and doesn't remember what the user selected. And so let's use local storage to persist the chosen mode, and let's see how this is done. On the left, you have the previous code that we were looking at without all the the basic HTML to render it. And on the right, we've got the same thing, but this time we're using local storage. So the way that we do that is we first write a method called getState from local storage. And all this is doing is it's creating a variable called storage, which looks for the mode in local storage. If it finds that, then it returns that the mode. If it doesn't, then it returns the default mode, which is light. We also have another method that stores the state in local storage. So it takes in mode as the state, as an argument, and then it sets the local storage to that key value pair of mode and the value of mode. And then within our actual functional component, we've got the same thing as we had previously, but this time useState has a default value that it gets from local storage rather than declaring it manually. And then we still have the same change mode method. And then we've got our two use effects over here. One is to update the document title, and two is to store the state in the local storage when it gets updated. And so now with this, if we refresh the page, you can see hopefully that the mode doesn't change. What if we wanted to persist more than just the mode? For example, if we wanted to choose a different song to wash our hands to and have our component remember the song that the user has chosen, or the user's name, or anything else that we want to persist in local storage, that's where a custom hook would come in really handy. So let's take a look at how we can continue storing the mode in local storage, but make it generic so that anything else we want to store in local storage, we can reuse the code with our custom hook. So this is the code on the left without the custom hook, and on the right, it's with the custom hook. And let's take a look step by step at how we've kind of migrated over this code. So first thing you do is you declare const use local storage, and it takes in an initial key, a key and an initial value. And then we move the get state from local storage into the use local storage hook. And you'll see here that the main difference is that without custom hook, we're specifically going to local storage and looking for an item called mode. And with local storage, we're saying, hey, get me whatever key I've passed you. And if you find that key, then return whatever value is associated with that key. If you don't find it, then return the initial value. Next thing we've done is we've declared state with value and set value. And instead of in the previous example, on the left, we've got mode and set mode, but here we're just using generic state value and set value, and we're saying set the state, so useState should come from the get state from local storage function there. The next thing is that we move the local storage updating code, which is local storage.set item, from that specific store state in local storage function into a use effect. So every time the component renders for the first time and anytime state changes, it will update local storage and it will set the item with the key and value pair that we pass it. And the dependency array has key and value. So every time key or value changes, it'll update local storage. And then finally, the use local storage hook returns a value and set value. And the way we use that is by saying mode comma set mode equals use local storage mode comma light, which is almost exactly identical to what we did earlier, but now instead of using state, we're using our custom hook mode and light. So tomorrow, if you want to use this for, what did we say, song and set song, you would say key is song and the value is staying alive, or I don't know, I can't remember any of the, we will rock you, or whatever you want to wash your hands to. And so this way, we are reusing our code and making it much easier to call local storage anytime you want to do that with something else. But why hooks? Hooks solve three main problems. One is wrapper hell. You've probably heard about this and probably seen this in your apps as well, where you have to, like, you see the shape of code where you have element inside an element, etc. And typically React components are surrounded by layers of providers, consumers, higher order components, render props, and using hooks in functional components makes it easier to reuse stateful logic and avoid wrapper hell like this, so you don't have to pass props up and down all over the place. And then we saw a really simple example of the lifecycle methods versus use effect. And what we saw in the lifecycle methods was we lumped together code that's related, that's unrelated, and we split up code that's related. For example, if you had a componented mount where you want to do some logic for data fetching, you would sometimes have it mixed in with unrelated logic to set up event listeners. And so basically, use effect mitigates that by letting you use as many use effects as you need to, so you can componentize or modularize your code and give it more context. And finally, classes. So when I was writing class components, which I don't anymore, but the main problem I had was, annoyingly, I would completely forget the syntax, or, miss a bracket or a curly bracket somewhere, and I had to constantly look that up. I often forgot to bind my event handlers, especially when I was using regular functions instead of arrow functions. And turns out this is a fairly common problem. And also, other than humans, machines also have issues with classes. They don't minify class-related code very well, which means your code is more bulky and will take longer to load and to parse, and this slows things down and affects performance. So hooks solve that problem as well. And why custom hooks? Because for the same reason we use functions, right? To keep your code dry, to make it more reusable and more maintainable. There's a whole host of custom hooks that you can find online that are already written for you. The one we had today that you saw, use local storage, that's something that you can reuse. You'll also find things like use dark mode, and I can't think of any more examples now. My mind's a blank, but if you Google it, you'll find a whole ton of custom hooks that you can use in your code or reuse in your code. In summary, hooks are excuse me, hooks are completely opt-in. They're backwards compatible, and they're JavaScript functions, that you can use in functional components to hook into the React API, and to create custom hooks. Um, Thank you very much. I hope you all stay well and stay healthy. And I would appreciate any feedback you have for me. Thank you. Bye.